Hey guys, my name is Iman and this is the third tutorial on Latin hypercube sampling. In this tutorial, I'm going to use Monte Carlo approach to approximate the area of the unit circle. As we know, the area for unit circle is pi, but let's assume we don't know that and we want to approximate the area for the circle using Monte Carlo approach. Let's enclose the circle inside a square. So basically each side can be a random variable. So we have two sides, x1 and x2. x1 and x2 are two uniform variables between -1 and 1. So if we want to solve this problem, if we want to approximate the area using Monte Carlo with n samples, here's the algorithm. We need to set the counter to 0. And then we generate one random number for each variable, one for x1, one for x2. If the point is inside the circle, we increase the counter by 1. If n is number of samples, so it can be 100, 1,000, 10,000. If n is not reached, go to step 2 and generate another random number and see if it's inside or not. So iterate many times until this loop is over. After the loop is over, area can be approximated by counter divided by total number of samples multiplied by 4. That 4 is the area for the square because, as I said, x1 and x2 are between -1 and 1, -1 and 1. So this length is 2, this length is 2. So the area for a square is 4. Now, different iterations of the same sample size might produce different results. What does that mean? Let's say n, number of samples, is 4. So for this iteration, 2 samples are inside, 2 samples are outside. So the result is 2 divided by 4 multiplied by 4. So we get 2. Another iteration. 1 sample inside, 3 outside. So the result is 1. Another iteration. 4 sample inside, nothing outside. So the result is 4. As you can see, for the same number of sample size, the results are quite different. So we need to increase n as long as different iterations of the same sample size still produce noticeably different solutions. In order to quantify that, I measure the distance between different solutions for different iterations. And then I say, okay, the maximum distance must be less than epsilon. So epsilon can be different from one application to another. Basically, again, we measure the distance between all the solutions, and then we say the difference for the same number of sample size must be less than epsilon. Here's the result. So again, we are calculating the area for the unit circle. So the area is pi. In theory, it's pi, 3.14. So that's the ideal, that's the exact area. But, as you can see, for the same number of sample size, for example, when the sample size is 2,000, we iterate 100 times and we get different results. 6,000, we iterate 100 times, we get different results. So for each sample size, I measure the distance between the solutions. And here is the maximum difference between solutions for the same number of sample size. As you can see, the main takeaway from this figure is, as you increase n, the maximum difference goes down. So basically, as you increase number of sample, the accuracy gets better and better. So the threshold, for example, if you set epsilon to 0.02, this is an acceptable number of samples. But, as I said, for different applications, you might have different threshold. If you need more accuracy, you need to increase number of samples more. So again, the main takeaway from these figures is, as you increase the number of samples, the results get more accurate, and the range is smaller. So basically, as you can see, the range here is from here to here. But as you go that direction, the range is getting smaller and smaller. That's why the maximum difference goes down. In next tutorial, I'm going to talk about Latin hypercube sampling. Thanks for watching this tutorial.